Hello everyone. In this video, I'm going to explain the Verilog implementation of integrating FIFO into the multi-threaded processor. This FIFO can be converted, it acts as both FIFO and data memory based on the control signals coming from the state machine, FSM. In this video, I'm going to explain the how process done signal is generated for the multi-threaded processor. I have implemented a counter which whenever a processing done signal comes, it increments and as we have four threads, I'm waiting for the flag counter to become 4. Whenever the flag counter becomes 4, processing done flag is set. When this flag is set in the state machine, FSM comes out of the CPU mode and goes into start mode. Whenever the state machine uh, comes out of the CPU mode, or whenever it is not in the CPU mode, the whole processor will be reset. That logic I will show here. As we can see here, reset signal is set high whenever processor is not in CPU mode. So whenever the FSM is not in CPU mode, the whole processor will be reset. And I'm taking out header pointer as output from the FSM and giving it to register file and storing it in the 31st register, which is used as the address, which holds the address of the starting packet which we need to process. uh, I will show the Verilog implementation of the register file. As we can see here, whenever there is a whenever we are in the CPU mode and end of packet comes, I'm storing the header pointer into 31st location of the register file. Whenever end of packet comes, the I'm giving an enable and I'm putting the header pointer into the 31st register, and this 31st register is acting as a special register which holds the start packet address of the current network packet which we need to process. As we can see, whenever we want whenever we are reading the 31st registers of all four banks, I'm redirecting the address to 31st register so that all the threads will read the address of the header from the 31st location. Also, in the previous video, I couldn't, in the lab 10, we couldn't capture the data packets in NetFPGA. That is because our logic analyzer was not updated properly. In this lab, we have updated our logic analyzer to capture all the necessary signals that we want to debug. Example, in data, in control, out control, uh, all current thread of the processor, CPU mode bit, and then process done flag. Everything we are capturing. Now I'll go through. Now I will explain in the logic analyzer why we couldn't capture the packet previously. As we can, what we observed in the NetFPA is that whenever the in data has come, then only we should capture the data into the logic analyzer. Previously, from the start, for the in the logic analyzer, without any control signals, we were just storing the data for the first 256 cycles. But when we ping, junk value used to get stored in the logic analyzer. So, but now, as you can see here, I am giving enable whenever the pipeline data reach 9th bit is high. That means in the from the processor, I am making sure that 9th bit is the logic analyzer enable. That when this is high, then only I am going to store it to the logic analyzer. Now, we are able to store the proper packet into the logic analyzer, and which is visible in NetFPG. I will go through logic analyzer enable signal, how we are generating it. As we can see here, I am setting logic analyzer enable set whenever I am in CPU mode, or whenever there is in write, or whenever there is out write, so that logic analyzer will store the necessary data instead of storing any junk value. And also in processor, I'm storing the current PC logic analyzer enable, current FSM state, CPU mode bit, processing done flag, reset signals, and flag counter, header pointer, all in data, out data, in all control signals and muxes, so that which it will be useful for us to debug in NetFPG. The Verilog implementation of the multi-threaded processor, I have explained it in Lab 11 video, and FIFO logic, I have explained it in Lab 10 video. So in this video, I have explained only necessary logic that we are adding to integrate FIFO into the multi-threaded processor. Yeah, thank you.